In the video today, we're going to discuss linear programming. You probably noticed that I've already written some equations down to make this video a little bit faster. Notice that we have our first equation is x greater than 0, and the red line shows my x greater than x equals 0, and if I were to say greater than 0, I would shade to the right of the red line. If it's y greater than 0, which is this horizontal line, I would shade above the blue line. Notice I'm kind of only shading where everything's going to intersect. Okay, the yellow line, which is y less than 3, is going to be below, and the green line is our equation 3x plus 4y less than or equal to 24, which I have to solve for y and make sure that I put that into y-intercept form so that I can go graph that. And so I've graphed the green line, and if I shade below it, it's basically shading below and intersecting with all of my other shading from the rest of the lines. So now notice that I have some vertices. I've got a vertex here, one here, one here, and one here. Okay? All right. So let's make sure that we use our correct vertices for this, because this is what linear programming is. Okay? When you have something, a set of graphs, let's say in a company, you had a set of graphs, and this is what happened last year. And let's say they're talking about cost or profit or something they want to be able to do next year. So what they say is, hey, can you find our minimum profit or our maximum profit, let's say. Because they don't want to work at their minimum, they want to try to maximize. So they want to know where their minimums are so that they stay away from that, and they want to go toward the maximum. Could be anything, sales, manufacturing. Anybody could come in and say, okay, this is what we want. So what they do is they look at last year, and they call this set of graphs that we have done, they call them the constraints. This is what happened, this is where we are, and so on. Okay? From the constraints, we're going to list our vertices. Okay, so I'm going to go, we're going to use 4 this time. Sometimes it's only 3. Could be actually any number. Okay, notice that this one up here looks like a vertex, but it's not. Okay, I'm only going to use the ones where there are my shaded areas. So instead, I'm going to use 0, 3. Okay, so I've got 0, 3, and then I've got 4, 3, and then 0, 0, very bottom one, and then 8, 0. Okay. All right. Now, for every problem that you get, you're going to get what's called the objective function. Okay. Our objective function is going to be P equals 10x plus 2y. Let's say the head of the company comes in and says, this is where we need to be working at. So what we need to do is test our vertices to see at what point we were, say, maximizing profit, or maybe it was a minimum. So we're going to ask on the quizzes and the test, it'll be what was your maximum and what was your minimum. So we're going to plot we're going to calculate each one of these. So let's try for our first vertex. The first vertex was 0, 3, right? So for the first vertex, we have 10 times 0, because 0 is the x, and 3 is the y. So that's going to give us a 6. I'm just going to write the answers down here for what p equals. Okay, so then we're going to do the next one. The next one is p equals, I'll write that like that, 10 times 4 plus 3 times 3. I meant to put a 2. 2 times 3. Okay, so that's going to give me 46. Okay. Do it again. I guess if I plug in 0 and 0, I'm just going to get 0 for the next one, aren't I? How about the next one? Times 8, and then I'll have 2 times 0. Times 0. Okay, I'm running out of room. We'll make that just a 0 there, since we know it's 0. And that'll be 80. Okay, so my maximum is going to be 80. And if I ask you to put the point, I'll say your maximum is 80, occurs at 8, 0. Notice that that looks like one of the lowest points on the graph, but it ends up being the maximum. So watch out for that. It's not necessarily the highest point. Okay? And my minimum occurs at the 0, 0. And it's not necessarily going to be the lowest point. Okay? Whereas this case, yes, 0, 0, I mean, that's going to be your lowest point. Okay? Well, that's it for linear programming. All you have to do is graph the constraints, find your vertices, and plug them into the objective function. Okay? The constraints will be given to you, and the objective function will be given to you. All right? Thank you for watching. Let me know if you have any questions.